Now let's discuss how to describe transformations. And we'll begin with this example. What is a composition of transformations that maps trapezoid ABCD onto trapezoid MNHP? Then we'll write the mapping a second way using what's known as XY notation, or coming up with a formula or operations that we can do with the X and Y coordinates to get the X and Y coordinates of our image. And the last thing that we are going to answer is, in this example, is your composition of transformations commutative? In other words, could you do the transformations the first way and then also do them in reverse? Well, let's actually see what happens. So we're mapping ABCD onto MNHP. Notice that in our pre-image, we're naming the vertices in a clockwise manner, and then in the image, we're naming them in a counterclockwise manner. That signifies a reflection. So we can reflect trapezoid ABCD across the y-axis first. Let's do that to begin. So 1, 2 with B, so we have to go 1, 2 again. So this will be where B prime is, or a middle step. For A, we have to go 6 units to get to the y-axis, so we have to go another 6 units. So this will be A prime. And then for C, we have to go to the right 1 unit to get to the y-axis, so we have to go to the right 1 more unit. This will be C prime. Now for D, we have to go 8 units, so we have to go 8 units again. So here's our middle step that we have here. And now notice that this trapezoid MNHP is smaller than trapezoid A prime, B prime, C prime, D prime. So because it's smaller, we're going to reduce it. So it's going to be a reduction. So if we were to draw lines from the origin through our points, we can see that they all lie on the same line. And this is very important. You can clearly see that point D prime and point P are on the same line. Point C prime and H are on the same line. A prime and M are on the same line, and B prime and N are on the same line. And because we're making it smaller, it's going to be a reduction. And if you notice, the distance from the origin to B prime is double that from the origin to N. So we're reducing our original shape by half. So what we have done so far is first we reflected across the y-axis. You could also write it as a reflection across x equals 0. And we did that first, so that goes as the second part because the dot means after. And we dilated our trapezoid by a scale factor of 1/2, and you can either leave it as a dilation with 1/2 in subscript, or you can put the 1/2 in subscript and also write 0 for the origin. Both of them are acceptable. Now the next thing that we need to do is we need to determine the formula. XY goes to what? Well, when we reflected it across the y-axis, our x-coordinates changed signs. That means the x-coordinate is going to be a negative, and then instead of it remaining just as x, we multiplied each x and y coordinate by 1/2. So we have negative 1/2 x and then 1/2 y. And now let's answer this last question. In this example, is your composition of transformations commutative? Meaning, if I would have dilated trapezoid ABCD first, with a scale factor of 1/2 and then reflected it across the y-axis, would I still end up getting the same value? So let's actually do that really quick. So if we reduced and showed the dilation or the reduction, we would have, I'm going to label it as B double prime just so that we don't get it confused with what's already over there. And then A, we would end up having it be, instead of at -6,2, it would be at -3,1. So this would be A double prime. Instead of D being at -8, -2, it would be at -4, -1. And then C would end up being at -1/2, -1. So if I have this trapezoid and then I reflect it about the y-axis, does it still land on trapezoid MNHP? And yes, it does. You can clearly see, if we draw the line of reflection in here, that you can map, you can do the reduction or the dilation with a scale factor of 1/2 first, and then reflect it across the y-axis second and still get the same value. So the answer to this one is yes. So again, you could write it as a reflection across the y-axis after a dilation with a scale factor of 1/2 of ABCD is equal to MNHP. You could also write it as a dilation with a scale factor of 1/2 after a reflection across the y-axis of ABCD is equal to MNHP. And yes, this composition is commutative, and our formula for xy maps to -1/2x, 1/2y. I originally wrote it as fractions here, but these are the decimal equivalents. Let's go over another example where we are describing the transformations that are happening from one polygon to the other. So describe and write symbolically in two different ways a composition of transformations that maps triangle ABC to triangle FGH. So we will write it as a transformation after another transformation of triangle ABC maps to triangle FGH. And we can also write it as algebraic ordered pairs. XY maps to what comma what. Like, what operations are we doing with the original x and y coordinates to get the new ones? So let's first begin by describing and writing symbolically in two different ways how triangle ABC maps to triangle FGH. So notice when we were naming, I was following the vertices going around. So in our pre-image triangle ABC, the vertices go around the shape clockwise. In triangle FGH, they go around counterclockwise. That always happens whenever you have a reflection. And we can see by the orientation of the shapes that the reflection is happening across the y-axis. So we're reflecting across here, and we'll get B prime will stay at point B. A prime, instead of being at -3,2, it'll be at 3,2. And C prime, instead of being at -3, -2, it will be at +3, -2. So we know that our first transformation, which has to go second because the circle symbol or the little O symbol stands for after. So we're doing something after a reflection across the y-axis. And since triangle FGH is bigger than triangle A prime, B prime, C prime, we have to enlarge it or dilate it with a scale factor that is greater than 1. So let's draw some lines through from the origin through our pre-image and image points to see if we can determine what the scale factor is that we are multiplying by to get the new points. So the distance from the origin to B prime is 2. That's going to be our pre-image, so that goes down below. And the distance to get from the center of dilation to the image point, point G, is 3. So our scale factor is going to be 3/2, or 1.5 if you write it as a decimal. We can also see this by taking the coordinates of our pre-image and image, like B prime, which is at 0, 2, and G, which is at 0, 3, and put the image point over top of the other to get 3/2, or 1.5. Let's see how this also holds true between point A prime and point F. So A prime has the coordinates of 3, 2, and point F has the coordinates of 4.5, 3. So if we take our image over the pre-image, we get 3/2 for the y coordinates. If we do 4.5 over 3, that's equal to 45 over 30 when we multiply both the numerator and denominator by 10 to remove the decimal. And that does reduce to 3/2, or 1.5. So our K value, or the scale factor for dilation that we are using, is either 3/2 or 1.5. So symbolically, our transformation will be a dilation with a scale factor of 1.5 about the origin after a reflection across the y-axis of triangle ABC maps to triangle FGH. Now, if we also look at the coordinates of our original points, A, B, C, so A is at -3, 2, C is at -3, -2, and point B is at 0, 2. Notice that our x coordinates changed sign. So we have a negative, and we multiplied 3 by 1.5 to get 4.5. So it'll be -1.5x, comma 1.5y for the formula that represents our dilation and reflection mapping. Now the last section of this question that we have to answer is to describe and write symbolically in 2 different ways. Well, if I would have dilated triangle ABC first and then reflected it, I would have still gotten the same triangle FGH. So therefore, we can also write our composition of transformations as a reflection across the y-axis after a dilation with a scale factor of 1.5 of triangle ABC maps to triangle FGH. So we could, like I said, we can say it reflected over the y-axis and then was scaled or dilated by a scale factor of 1.5. And we can write that as the dilation with a factor of 1.5 after a reflection across the y-axis of triangle ABC is equal to triangle FGH. And again, as stated, you could have also scaled by a factor of 1/2 first and then reflected it over the y-axis. And the symbolic notation for that is the reflection across the y-axis after the dilation with a scale factor of 1.5 of triangle ABC is equal to triangle FGH. And in the symbolic notation, we did get that x comma y maps to -1.5x comma 1.5y. Here's another example where we are describing transformations. Describe and write symbolically a composition of transformations that maps triangle ABC onto triangle FGH. The First thing that we can notice is that when we're naming our two triangles, triangle ABC and triangle FGH, we're traveling around each shape in a clockwise manner. That means that because the orientation is different, but the order and the direction in which we are naming the vertices in our triangles are the same, this has to be a rotation. It can't be a reflection because that switches the order when the vertices are named from a pre-image to an image. So since the order is staying the same and the direction is the same in a clockwise manner, we're going to have a rotation here. So let's start with that. We have a rotation. Notice we're going from AB being horizontal to FG being vertical. So it's going in this direction. So it's a rotation of 90 degrees counterclockwise about the origin. Okay, that's our first transformation that we have. And let's actually draw that 90-degree rotation. So point B, we're going about the origin. To get from B to the origin, we have to count downward 4 units. So in order to rotate it counterclockwise, we have to move to the left 4 units. So this will be where point B prime occurs. And point A prime, we have to move down 4 units and to the right 2 units to get to the origin. So the slope of this line to get to the center of rotation, the slope here is -2. So the slope for our new line will be the opposite reciprocal, so it will be +1/2. So this will be where point A prime will be. The slope here is +1/2. Okay, and now we have to move point C 90 degrees. We have to rotate it 90 degrees about the origin. So we have to go up 2 and to the right 4. So in order to rotate it 90 degrees in this direction, we're going to go down 4, 1, 2, 3, 4, and to the right 2. So this will be where point C prime is. So after the rotation of 90 degrees, our triangle will look something like this. Actually, let me redraw those with straight lines instead to make it a little more clear. AB isn't that bad. There, that's more clear. We can now see how triangle ABC maps to triangle A prime, B prime, C prime. And now if we connect this image triangle to our center of dilation, the origin, we can clearly see how it's also crossing over our image points. So as a result, we are dilating with a factor of, notice we went from 4 to 2, we went from 2 -4 to 1 -2, so it reduced by a factor of 1/2 or 0.5. And now to finish off the notation, we're going to write down our colon and write in our pre-image triangle, triangle ABC, and the dilation with a scale factor of 1/2 after a rotation of 90 degrees about the origin of triangle ABC equals triangle FGH. Now the question is, could I have also dilated it by the scale factor of 1/2 first and then rotated it? The answer to that one is yes. So therefore you could also rewrite this solution as a reflection of 90 degrees about the origin after a dilation with a scale factor of 1/2 of triangle ABC is equal to triangle FGH.